Okay, welcome. This is Math 240, Module 7, Project 2, Helper. First, let's review what a hypothesis test is. Say, for example, we want to claim the average grade level reading score of this year's third graders is higher than last year's average grade level reading score, like what grade level students are reading on. Last year, the average was 2.07. A sample of third graders is taken, and the student's reading grade level was recorded, and the average was 2.08. Is this higher? Yes. Significantly higher? No. 2.08 and 2.07, very close. Okay, it's not significantly higher. What if this year's third graders had a mean of 3.14? Yes, that's significantly higher. This could just be a fluke where maybe this year had a little baby Einstein, some like very smart little kid, and it's just some random fluke where that is extremely higher. Okay, so a hypothesis test uses sample data to make a guess about an entire population. Okay, we can't just take a sample and say that that's from the whole population. Remember, sample is part, population is the whole. Okay, I can't say that 30% of students in my class are left-handed and then say that that means all people in the world, 30% are left-handed. Okay, so let's get started. You're going to download the real estate file. Now, I understand that we've had the real estate file before, but it's a little different because it's set up separated by region and tabs. Of course, our word template from the guidelines and rubric, and then the national statistics PDF. All of those in the learning module in Brightspace. Okay, so introduction, the first section from the template, you're going to specify the region, and there's only a certain number, there's only certain regions that we're going to select from. That is because some regions don't have at least 500 homes, don't have enough homes to take a sample. So be sure to pay attention to the template. Only select what is listed in the template. Okay, our purpose, we want to compare a region to the national statistics for the list price, and then we're also going to compare a region to the national statistics for square feet. So we're using list price for one part and square feet for a different part. Okay, sample, define your sample. Take a sample of 500 house sales, and we're going to describe what's in the sample. So we have states, regions, square feet, and list price. Okay, our two hypothesis questions. Okay, our two hypothesis questions, we're going to um, talk about that. Our first hypothesis, our parameter is the mean list price of whatever region. In words, we're going to say, I believe the mean list price of whatever region you select is less than 288,407. Okay, where did I get that number? That is from the PDF of the national values, which I will show you when we look at the Excel file. Okay, so in symbols, we're going to say HO, which is the null hypothesis. The mean is 288,407. Now, in the Word document, it says we want to test that the mean of our region is less. So we're using our alternate hypothesis, the mean is less. Okay, use 288,407. Don't use any different numbers. Because the standard deviation is unknown, we use the t-distribution. Because our alternate hypothesis has less than, we use left-tailed. Okay, our second hypothesis is the parameter is the mean square feet of our region. Okay, now here, the parameter is the unknown value. It's not your sample mean. It's the unknown mean for the entire region. Parameter means all of it, all the homes ever. Okay, now in this claim, it says, I believe the mean square feet of blank region is different. Okay, different doesn't mean less, it doesn't mean more, it means not equal. And where did I get 1944? From the national values of the mean square feet. Okay, so this will be your HO and HA. Now, if you notice in the last one, I typed the word mean. Here I used mu, our Greek letter. You can find those in Microsoft Word under Insert Symbol, but you can just type the word mean. Either the symbol or the word mean has to be in that because there are different tests for different parameters. So you've got to put either the word mean or the Greek letter mu. The standard deviation is unknown, t-distribution. The alternate hypothesis has not equal, so we use two-tailed. Okay, we're going to use estimation by finding sample mean and confidence intervals for our test. Okay, the next section, one tail test. I'm just going through the template here. Once again, the parameter is the mean list price of blank region. Insert what region you chose. In words, I believe the mean list price of blank region is less than 288,407. And there's our symbols, our symbolic HO and HA again. Do not deviate from this. The significance level, alpha equals 0.05. Okay, you can type alpha, once again, Greek letters in Microsoft Word. Click Insert Symbol. Okay, now it's going to ask about if it's normally distributed or if it's skew. Okay, about the data analysis section, when you look at your histogram, remember this is normal on the left, it looks like a bell, and then skew, there's two skews, left and right. Okay, now why is left skewed got that big hump on the right side? Okay, think about if um, you have an average of something, but there's a few smaller values. That brings the average down, which is what left skew means. Okay, let's say a student has a whole bunch of good grades, and then there's a couple zeros. Well, those zeros are going to bring the average down. Okay, similarly, okay, right skew. What does right skew mean? You have a bunch of values that are all similar. Okay, think about a company, the average salary for a company. Okay, but you've got these CEOs, these higher up presidents and stuff making bank. They got real high salaries. Like most people make like 80. And then you got these big wigs making millions of dollars. Well, that's going to bring the average higher than what most people make. Okay, that's what skew means. Okay, so the one-tail test, we're going to find our summary statistics, mean, median, standard deviation, our quartiles, a histogram, and then we're going to talk about the shape. Okay, in the data analysis, compare the mean, median, standard deviation from your sample to the national values. Okay, is it higher? Is it lower? Is it a big difference? A small difference? For the assumptions, our assumptions are a random sample, which we're going to use our random function in Excel, and large sample size. Okay, so next we're going to go to Excel. Okay, so when you download it, let me just make sure it's switched to correct screen share. Okay, so when you download it, this is what it looks like. And you can see it's different because we have our different tabs here for all of this. Okay, so I believe I chose West, South, Central. Okay, so here we have West, South, Central, and you can see we've got a lot of data. Okay, I'm not going to go through all that. So we want to find our random sample. So go to a blank cell, equals RAND. Okay, that's what I do. I just start typing. Okay, random number, enter. Okay, now we want to fill that down. Sorry, I went a little too far. Okay, there's probably another way to do this, but fill to make sure you go to the bottom. Fill down. Okay. Now, remember, just putting the random number, that didn't do anything to these rows. Okay, all that did was put another number there. We have to sort this column to make this truly random. Okay, so we want to sort and filter by this column. Okay, remember, let me just click somewhere else. Okay, you don't want to click a cell, you want to click the column. Okay, sort and filter, smallest to largest. Now expand the section selection. Yes, because each row represents a house. So we want to make sure that this 149050 stays with each of these numbers here. So yes, expand. Okay. And then we want to take 500. Okay. What I like to do is cut and paste. Okay. So you want to take 500 of these and cut and paste. Okay. Now, all we really need is list price and square feet. Okay. So either cut and paste or copy and paste to a new sample. Okay. Which I've done here. Okay. Now, I've done a few things here. Let me delete all that. Okay, so list price, of course, is our numbers in like hundreds of thousands of dollars. Okay, now you can use the data analysis tab. Okay, remember data analysis. I'm just going to use these formulas, okay, because sometimes students can't get the data analysis, so we'll just make sure we know how to do it this way. Now, I like to just start typing, okay, to do a formula equals, okay. Now, not average deviation, we want average, okay. Now, we can highlight or you can just do this. My numbers start in A1, okay. You have to use a colon to make sure it does all of them, okay. A1 colon A500, okay, because that's where my list price is. Okay, now here, see how it's rounding? Let's make everything in dollars and cents. So if you increase your decimal, we'll have that here. Okay, now this one is equals median. Same thing, A1, A500. Okay, sample standard deviation. Now that function is STD EV. Now the dot S is the one we want because we want the sample. So A1 to A500. Okay, Q1 is the quartile function. Okay, just quartile. Same thing, A1, A500. And okay, too few arguments. What does that mean? That means there's something else. You have to tell it the quartile. So, comma, 1. Okay, and I've put this out to the side. Standard deviation, and then what the arguments are. Okay, first cell, last cell, and so forth. Okay, so this one is also quartile. A1 colon A500 and the third quartile. Okay, minimum, you don't have to do that. I just thought it would be a nice thing to show because this is what is, these values are our 5-number summary in terms of mean, median, the quartiles, and the max. Okay, it might be a nice thing to put in your report, in your data summary. Okay, our sample size is 500. Now I'm going to increase the decimal on these. Okay, well, oh, well, those numbers are whole numbers, so that makes sense why the quartiles, those are whole numbers because our data is whole numbers. Okay, we need the square root of the sample size for the standard error. Okay, if you do data analysis, it'll come up in that. Okay, so the square root is equal SQRT. Double click it. Okay, you can type 500 or just reference the cell. The standard error is the sample standard deviation divided by the square root of the sample size. So that's going to be sample standard deviation divided by the square root of the sample size. Okay, so it's very easy just to reference a cell. Equal is a formula. Okay, now our test statistic, you take the sample mean and subtract the mean from the hypothesis, divide by the standard error. Okay, so equals. Now, these parentheses are very important because we have to have the subtraction done first, then the division. Okay, so sample mean minus the mean from the hypothesis, close, divide by. Now, our standard error is right here in this cell. So let's just click it. Okay, now that is very far away from our sample mean and our hypothesis. Okay, that's a very big difference here. Okay, the p-value is left-tailed because we had the alternate hypothesis is left-tailed. So this is equal the t-distribution. This is left-tailed. Okay, what are the arguments here? What do you put in? Okay, our test statistic is in D16, comma, degrees of freedom on this is 1 less than the sample size. Sample size is 500, so 499. Now, cumulative, yes. So you can double click true or you can type true. Okay, so that's our p-value. Now, what is a p-value? P-values are probabilities. They have to be between 0 and 1. So what does 2.34 E minus 60 mean? It means move that decimal left 60 times. So that's like 0.0, a whole bunch of zeros, and then at the end, 234. Now, obviously, that's not moving it 60 times, but that is practically 0. Okay. Let's do the same thing for square feet. Square feet is our column B. Okay. So we have equals average, B1, B500, equals median. Okay, you got to double click it, to, or you can type all this. B1, B500 equals standard deviation sample, B1, B500, Q1 equals quartile, B1 colon B500, comma, first quartile equals quartile, double click, B1 colon B500, comma, third quartile equals the minimum of B1, B500. Okay. The max equals max B1, B500. This is 500 sample size. Okay. We need the square root of 500. Our standard error is the equals sample standard deviation divided by the square root of the sample size. Okay. And same thing here. I put the arguments, the formatting for these formulas. Okay. Our test statistic, same thing. We take our sample mean. Okay. So it equals, open parentheses, our sample mean. We're just going to reference our cell, minus, now we're testing, this is 1944, close parentheses, divide by our standard error, just reference your cell, easiest thing to do. Okay, so that is our test statistic. Okay, that's our test statistic. Okay, which is a positive number. Now, our p-value is going to use the two-tail, and that is because our alternate hypothesis is not equal. Okay, so this equals T dot distribution two-tail of, where is our test at? In this cell, degrees of freedom is 1 less than the sample size. So 500 minus 1 is 499. Okay. Now, once again, see this E minus 13? That means this is like, move that decimal left. So we're going to have a bunch of zeros and then that 5, 4, 0, and so forth. Okay, that E minus 13 means move that left 13 times. Okay, so both of our p-values are practically 0. Okay, now what if your test statistic is negative? For the two-tailed test. Okay, for some reason, Excel is kind of strange. You can do two things. Okay, you can do two things. You can either use the positive value. So let's say you get -3 as your test stat, and you try to use the two-tail test. Okay, equal T dot distribution two-tail. For this, it comes out with an error. Okay, The two-tail distribution means you have your left tail and your right tail. Okay. What would make you think the mean was not 1944? Either a mean that's extremely higher than 1944 or extremely lower than. That's what two-tail means. It could either be way higher or way lower. So you can do two things. You can either just change this to a positive, which is the easiest thing. Okay, and I'll show you why this comes out the same when I go back to the PowerPoint. Okay, or you can find the left tail of -3 degrees of freedom. Cumulative is true. Okay, well, you got to type true correctly. True. Okay, so this is the left tail. The probability that t is less than -3. Okay, well, because this is symmetric, two-tailed is the left plus the right, which is 2 times the left side. Okay, so the two-tailed probability, p-value, watch, it's going to match what I did over here with using the positive statistic test stat. So this equals 2 times the left tail. Okay, and you can see these came out the same. If I make this bigger, okay, you can see how it's the same. Okay, this one's probably the easiest thing. If your test statistic is negative for two-tail, just make it positive, and I'll show you why on our PowerPoint. Okay, speaking of which, we'll go back to that. Now, the other calculation is we have to find the confidence interval. A confidence interval uses a margin of error. Okay, so what is the confidence interval margin of error? We use the confidence function. Okay, we're using t-distribution. We don't know the sample size. Okay, our alpha is 0.05 because it said a 95% confidence interval. We're using our standard deviation. Refer back to the cell, comma, size. Okay, that means sample size, which is 500. Okay, now I should have mentioned this. We're finding the confidence interval for square feet only. Okay, it's asking us just for that confidence interval for square feet. Okay, I know I have a typo, but I know you know what I mean. All right, the lower limit is, okay, a confidence interval for square feet. Our sample mean minus that error is our lower limit. Let me type this here. Sample mean. Okay, this is our sample mean. Our upper limit is the sample mean for square feet up here in O2 plus our error here we just calculated, which I've got in O23. Okay, so you subtract and add the error. Remember, that's like give or take. I think it'll take me between 1 and 2 hours to cut my front yard. Okay, so that is all our calculations. Let's go back to the PowerPoint. Let me just make sure I'm sharing the right thing. Okay. All right, let's do our interpretations. Okay, so the first hypothesis, what does all of this mean? Okay, here's an example of a left-tailed test. What does that p-value represent? Okay, here's a t-distribution with a test statistic of -2 and a left-tailed test. It asks you about where the test statistic is and what the p-value is. So you don't have to draw a graph. All you do is you could just describe this. Because the test statistic was negative, it's on the left side of 0. Think about a number line. The p-value of a left-tailed test is the area below that test statistic. Okay, see how it's small? Now, this is not our actual one. Our actual one is too small to really see on a graph. So this is just an example of a different one. The red area represents the p-value, which is the probability that HO is true, which means it's the probability the mean is that value given this data. Okay, so in your report, remember, state your p-value. It cannot be more than 1. You don't have to type this. Remember, it's between 0 and 1. I'm telling you this to make sure when you state your p-value, don't say that it's more than 1. Okay. I did forget to mention that your p-value, okay, if you don't see it, if you see this, okay, or something smaller, okay, it's almost never 0. You need to make those cells bigger so that you can see that. Okay, it's never going to be exactly 0 or 1. It's just not likely to happen. So you need to make sure you stretch those cells out so you can see that. Okay, you also have to compare it to our significance level of 0.05. So in your report, say what your p-value is. Tell me if it's more or less than 0.05. Remember, we line up decimals when we're comparing numbers. So 0.008 is smaller than 0.05. They both have a 0 after the decimal. This has a 0 in the second place, but this has a 5. So 0.0 is smaller than 0.5. But 0.11 is more than 0.05 because you start with that first decimal. Okay, 0.1. 1 is bigger than this 0. You make your decision. Okay. Now, don't write this in your report. Okay. Don't write all this. These are my instructions to you. These are the only two things. You can type this verbatim, and that is fine. Okay, you can type this exactly as it is because this is what we say. The p-value of blank is less than the significance level of 0.05, reject HO. There is enough evidence to support the claim the mean list price is less than 288,407, and you can type in your region. If your p-value is more, the p-value of blank is more than the significance level of 0.05, fail to reject HO. There is not enough evidence to support the claim and the mean is less than 288,407. Okay, see what I have in quotes? You should type one of those based on your p-value compared to 0.05. Okay, don't type this, make your decision. These are the only two options. Those are my instructions to you. Okay, what's in quotes? Type it exactly. Okay, our second hypothesis test, we did all our calculations. Okay, we've got our mean square feet, our HO, we're using T. Our alternate has not equal because I believe the mean is different. Okay, this right here, all of this, type all of this. Okay, this is basically exactly what you need to write up. Okay, we're going to do the same thing. We're going to make our comparisons. Our assumptions are the same. Okay, I did the Excel all at the same time for that. Okay, what's our interpretation? Here's an example of a t-distribution. And let's say the test statistic is like -2 something. Okay, so our orange area represents the p-value for a two-tailed test. The left and the right are the same area. These orange sizes are the same area. So that is why you can, if your test statistic is negative and Excel doesn't like that, you can change it to just finding for the two tail. If your test statistic is negative, you can just find the two tail for +2, because what that's going to do is add these two together. They're the same size. So that's why we can find the two tail for +2, and it's going to give us that double area. Okay, same thing. State your p-value. It can't be more than 1. You don't say that in your report. Don't say the p-value has to be between 0 and 1. That is me telling you that so that you know not to say it's more than 1. Just say what your p-value is, compare it to 0.05, and then same thing, make your decision. Pick one of these two quotes. If it's less, reject, enough evidence. If it's more, fail to reject, not enough evidence. Now, the only thing we can say on this test is that it's not 1944. We can't say the mean is more. We can't say it's less. We didn't test that. So the only thing that you can say is it's not equal. Okay? Find your confidence interval. Interpret it in terms of the test. Okay, so we already did the Excel. Now, how do we interpret the interval? Let's say we get an interval between 1940 and 1950. I know those look like years, but remember, we're talking about square feet. Okay, so there's two things that could happen. 1944 is in the interval, 1944 is not. If it is, this means the mean could be 1944 because we're estimating the mean is between our two numbers that we got in Excel, and 1944 is in this range. If 1944 is not in that interval, say for example 1910, 1930, this means the mean is most likely not 1944 because we're estimating the mean is between these two numbers. And 1944 doesn't fall in this range. Okay, so what does that mean? If 1944 is in the interval, your two-tailed test conclusion is most likely fail to reject because that means we keep believing HO, the mean is 1944. If 1944 is not in your interval, your two-tailed conclusion is most likely reject HO. There's enough evidence to support that it's not. Okay, now what does this mean? This means that you can say that your confidence interval is um, giving the same results as your test. Okay, these are the two ways we do testing. We either use a confidence interval or p-value or critical values. Okay. All right, reminders, Excel always gets uploaded. Leave it in Excel form, leave Word document in its form. Okay. Please remember to edit the cover page. All right, delete instructions and back brackets, repetitive headings. What do I mean by repetitive headings? Okay. If you notice in the project 2 template, Okay. Okay. Remember, delete this. That's do that. Okay. Take the brackets off of everything. The brackets just mean you're replacing that. Okay. We want this to be in a nice professional look. Okay. Please delete all the instructions. You're making your Turnitin scores unnecessarily high. Okay. So see how where it says first hypothesis, first hypothesis, first hypothesis? You don't need to say first hypothesis all the same time. Okay. Matter of fact, you can really delete um, delete some of this stuff. Second hypothesis, like this. Okay. Under one tail test, see how it all says hypothesis, hypothesis, hypothesis. Okay. Delete all that. Okay. All those extra hypotheses is extra. Same thing with data analysis. There's no need to have data analysis typed so many times. Okay. So just have data analysis as one little thing here. Okay. Just there's no need to say data analysis all these different times. Okay. Same thing, interpretation. Just say interpretation one time and put all of that. Okay. Same thing with your calculations. Just report your answers. Okay. Summarize your findings. Here, just type conclusion. Just type your conclusion. Okay. That'll get rid of some of the unnecessary Turnitin scores. Okay. Screenshot your histograms. Now, make sure they're stretched out in Word. And I did not do the histograms in Excel. I apologize. Let's go back to that. Okay. Okay. A histogram. There's two histograms that we need. We need one for list price. Okay. So you can highlight your numbers, insert, okay, histogram, histogram. Okay. Now, this is just list price. We're not doing scatter plots. This is list price. Now, you can't make interpretations when you've got these dot, dot, dots. What are those numbers? You need to stretch it so that you can see those numbers. You can't make interpretations without any numbers. Okay. Now, what do the numbers mean? This, the height of this bar, see how it says value 8? That means there's 8 homes that fall in this range of price. Okay, if I hover 65, there's 65 houses that fall in this price range. Okay, and same for all of the heights of these bars. Okay, access titles, we want that. I just click the plus and check mark the titles. Okay, this is still list price. Okay, now what's the height? The height is the frequency, and I deleted that. Okay, I just double clicked there. Frequency means count. How many houses fall in each range? Okay, do the same thing for square feet. So you can just highlight the column, insert, histogram, click it, move it, double click here. This is square feet. Okay, and our titles. You can put your region in there in your title. That's a good thing. Okay, double click in there. Frequency. Okay, so there's our charts. Now, when you don't, please don't copy and paste. It just doesn't go to Word very well. Now, sometimes when you put your histograms for list price in your Word document, okay, sometimes the picture is not big enough. So when you go to your Word document, make sure your picture is big enough. Okay, stretch out the picture in the Word document also. Okay, all right. Make sure they're stretched out in the Word document so you can see those. You'll have two, one for list price, one for square feet. You do not create a scatter plot. Scatter plots are seeing the relationship between two variables. We're not doing that. And that is project 2. Thank you for watching.